Hello dear students, welcome to the second video of relations and functions. So in this video we shall discuss about what are relations. So basically you have heard the term relation in your daily life. So what do you mean by that? By using this term we used to connect two person or two elements and mathematically to sets. So for example, if I take two sets, suppose this is the set of person and this is set of another person. Now here let me take three elements, suppose David, John and Joe, and here let me take Rome or anything, Jill, and here Jack. So suppose these are persons or six person we have taken. So what is the Cartesian product of A and B will be? So the Cartesian product will be David will be connected to Rome, David will be connected to Jill, and David will be connected to Jack. John to Rome, John to Jill, and John to Jack. Joe to Rome, Joe to Jill, and Joe to Jack. So here the number of elements of A is 3 and here the number of elements of B is 3. So the total number of Cartesian product of A and B is 9, isn't it? That means if we can form the ordered pair like this, like David and Rome and so on. Fine. Now what is a relation? Actually relation is the subset of Cartesian product of two sets. So here if I take the Cartesian product of AB, what will be it? It will be the set, suppose David, Rome, and David, Jill, David, Jack, then John and Rome, John and Jill, or John and Jack, and so on, and one more, suppose there will be three more. So let me take Joe and Jack. So here will be Joe and Jill, and one more, that is Joe and Rome. Okay, fine. So this is the cross product or the Cartesian product of these two sets. Now if I define a relation R and it is defined as, suppose, is the brother of, let me define relation like certain persons from the set A is the brother of certain person from the set B. So basically it cannot be possible, it might be possible sometimes, but in general we cannot see that a particular person or all the persons here are the brothers of these persons. So I can have by our assumption that David is the brother of Rome, so I can write David and Rome here. Then I can write John is the brother of, say, Rome, John, Rome here. I can write Joe is the brother of Jill. So suppose these three persons are brother of each other. So in such a case we can see that this particular three ordered pairs is the subset of A cross B, isn't it? So we can say that R is a relation. So mathematically if we see, if we take two sets, or if we want to define a relation, we need two sets, A and B. So a relation R will be a subset of A cross B always, where A cross B is a ordered pair where A belongs to the first set and B belongs to the second set. Fine? Okay. So let me consider a set A is equal to A, B, C, or A1, A2, A3, and B is equal to 1, 2, 3, 4, 5. And let me draw or let me define a relation. So here it is A1, A2, A3, 1, 2, 3, 4, 5. So here A1, let it be connected to this. Let this be connected like this. Fine. Now we can see that this A1 is connected to 1, A1 is connected to 2, A2 is connected to 2, A2 is connected to 4, A3 to 3 and A3 to 4. So if I write the relation like this, it will be A1 comma 1, A1 comma 2, then A2 comma 2, A2 comma 3, sorry not A2 comma 3, A2 comma 4, then A3 comma 3 and A3 comma 4. So I have written this relation in roster form. Fine. So I can also write certain relations in set builder form, and this is called the arrow diagram, or if you give an arrow here, this is called the arrow diagram. Okay, so generally a relation can be represented in three ways. The first one is roster form, the second is set builder form, and the third is this arrow diagram. Okay, also from this definition or from this relation we can define a thing that here, what is domain and range? Let me consider another element A4 here, and this is the set A and this is set B, and we see that A4 is not connected to any of the elements. So what is the domain of A? Domain, or not domain of A, actually is the domain of R. So what is domain of R? It will be the elements which are connected to certain elements of the set B. That is, here the domain will be A1, A2, A3. We shall exclude 4. Okay, so these are the domain. What is the range? Range of R. So range of R are those elements which are connected to at least one element of the set A. Okay, so what are the ranges? It will be 1, 2, 3 and 4. 5 is not connected to any of the elements, so we shall not consider 5 in the range part. What is codomain or codomain of R? Codomain of R will be all the elements of the set B. That is, it will be 1, 2, 3, 4 and 5. Also remember that the set 1, or sorry, the element 1 is called the image of A. This is the image of A, or A1. The element 2 is the image of A1 as well as A2. The element 3 is the image of A3. Element 4 is the image of A2 as well as A3, and element 5 is not the image of any of the elements. Okay, also A1 is the pre-image of 1, A1 is also the pre-image of 2. So this is how we define a relation, and these are the properties of the relations. So let us see a practical example, or mathematical example rather. So let us consider A is equal to 1, 2, 3, 4, 5, 6, and let us define a relation from A to A, okay, by R is equal to Y is equal to X plus 1, such that X comma Y both belongs to A. Fine. So we have taken this relation. Okay. Now we need to we shall find out what are the domain, codomain, range, and this relation has been written in the set builder form. We shall write it in the roster form, and also we shall write it in the, we shall show it in the arrow diagram. Okay, so at first let us go for the arrow diagram. Here this is the set A, and it is said that R is a relation from A to A. So both the sets will be A. Now let us write the elements first. It will be 1, 2, 3, 4, 5, 6. Here also it will be 1, 2, 3, 4, 5, 6. Fine. Now what does the relation say? It says that Y is equal to X plus 1. So X belongs to A first. So if X belongs to A, what is our x first x is 1, so 1 plus 1 will be 2. That means 1 is connected to 2 here. Again, if I take the second element, 2 plus 1, that is 3, 2 is connected to 3. Third element, 3 plus 1, 3 is connected to 4. Fourth element, 4 plus 1, 4 is connected to 5. Fifth element, 5 plus 1, 5 is connected to 6. Fine. So if I write them in the roster form, it will be 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5 and 5 comma 6. So thus we have written the relation in the roster form as well as in the arrow, as well as shown in the arrow diagram. Now what is the domain of R? Domain of R is 1, 2, 3, 4, 5 excluding 6. Range of R, what is the range of R? It will be all the elements that are connected to at least one element of the domain. So it will be 2, 3, 4, 5, 6. And codomain of R, there will be all the elements of the next set. There is 1, 2, 3, 4, 5 and 6. So that is all about the relations, and now we shall proceed to exercise 2.2. Let us see the first question here. That is, let us see question number 2. Here it is given that define a relation R on the set of natural numbers by, here the relation is given R is equal to x comma y such that y is equal to x plus 5, and x is a natural number less than 4, and x belongs and xy belongs to n. Fine. So this is the condition given. Now what can we write this in alternate form? xy such that y is equal to x plus 5. X is a natural number less than 4. That means I can write x is less than equal to 4, or just less than 4, not equal to 4. And x comma y belongs to the set of natural numbers. So alternately I can write it like this. Now the question is depict this relation using roster form. So in roster form, how shall we write this? If our values of x is less than 4, that means our natural number starts from 1, isn't it? So we shall have the values x equal to only 1, 2 and 3. So if we put x equal to 1, what shall we have for y? For x is equal to 1, we shall have y is equal to 6. For x is equal to 2, we have y is equal to 7. And for x is equal to 3, we have y is equal to 8. So in roster form, we shall write the elements as 1, 6, 2, 7 and 3, 8. Fine. So this is how we have got the relation in the roster form. Now the second part is that write down the domain and range. So what is the domain of this relation? Here domain is equal to, domain means the first element of the ordered pairs. So it will be 1, 2 and 3, and range is the second elements or the alternate elements of the ordered pairs, that is 6, 7 and 8. Fine. So it's very easy. Now let us see question number 6, that is determine the domain and range of the relation R defined by R is equal to x comma x plus 5. So let us write the relation here. R is equal to x comma x plus 5 such that x belongs to 0, 1, 2, 3, 4, 5. Okay, so this is our relation. We need to determine the domain and range of the relation. Okay, so what is this? If I want to write it in the roster form, here x belongs to 0, 1, 2, 3, 4, 5. So I can simply write the first element, that is the elements from the domain. Here I can write 0, then here it will be 1, 2, 3, 4, 5. Fine. Is there any other hint available here? Find by this. Okay. So now what will be these elements? That is the images of 0. So here x is 0, so x plus 5 will be 5. X is 1, it will be 6, 7, 8, 9, 10. So this is our relation. So what will be the domain? Domain will be the first elements, that is 0, 1, 2, 3, 4, 5, and they've asked to find the range. So range will be 5, 6, 7, 8, 9 and 10. Fine. So a very easy question. Next, let us see question number 7. Question number 7 says that here question number 7 says that write the relation R is equal to x comma x cube, where x is a prime number less than 10. So we need to write this in the roster form. How to write this? Now for this we need to understand what are the prime numbers those are less than 10. So here I can write x cube, and x is a prime number less than 10, so that means I can write x belongs to the set 2, 3, 5, 7, isn't it? So if this is the property, that is x belongs to this set, so here it will be 2 and 2 cube, then 3, 3 cube, 5, 5 cube and 7, 7 cube. So if you calculate this, it will be 2, 8, 3, 27, 5 cube is 125 and 7 cube is 49 to 343. Okay, so this is your question number 8 done. Now question number 9, you can, this is question number 7. Question number 9 you can try yourself. Just you need to use the property there is a minus b is an integer. Fine, and then find the domain in range. And question number 8, here it says let a is equal to xyz. Let a is equal to xyz, and what is b? It is 1, 2. So find the number of relations from a to b. Now this is an important thing. Here we see that number of elements of a is 3 and number of elements of b is 2. So how to find the total number of relations from the set A to set B? So it can be done easily. At first we know that number of elements of A cross B is equal to what? Is equal to number of elements of A into number of elements of B, and that is equal to 3 into 2 will be 6. Fine. Now total number of elements or total number of relations from A to B is given by 2 to the power 6. So from where we have collected this, it is actually the same number of subsets of the Cartesian product of A and B. So earlier in a problem, in the previous video, we have done a problem that is total number of subsets of A cross B. So we have got 2 to the power n number of subsets. So this total number of relations is same as the total number of subsets, that is 2 to the power 6, and that is equal to 4, 8, 16, 32, 64. Fine. Okay, so this will be the end of our exercise 2.2, and in the next video we shall come up with functions. That is the most important part of this chapter, and we shall solve exercise 2.3. So till then, stay home and stay safe. Thank you.